Greetings, everyone. Welcome back to my YouTube channel, Money Math, where I help students prepare for external examinations like IGCSE, WAEC, and Checkpoint. Today, we're going to be looking at Cambridge IGCSE, October-November 2022, Paper 4-2. Get your papers, get your pen, and let's get started. Question 1. At a football club, season tickets are sold for seated areas and for standing areas. The cost of season tickets are in the ratio seated ratio standing equals to 5 ratio 3. The cost of a season ticket for the standing area is $45. Find the cost of a season ticket for the seated area. So, um, the first thing we need to do is to represent. So let the total cost be T. So the cost of the standing area is $45, and this is the ratio for the standing area. That's 3/8. Remember, you have to add up this 5 plus 3, and that's it. So 3/8 times the total is equals to 45. So the total is 45 times 8 divided by 3, which will give us $120. So that means the total cost is $120. If the total cost is 120 and the cost for the standing area is $45, we can easily get the cost for the seated area. That's 5/8 times 120, and that will give us 75. So the answer here is $75. Question 2. In 2021, the value of the team's players was $2.65 million. In 2022, this value has decreased by 12%. Find the value in 2022. So the first thing you need to do in order not to mix things up is to change this to all figures. So when you change this to all figures, you have 2.65 million times 1 million, and that's going to give us 2,650,000. Okay, so we need to find a value in 2022 since it has decreased rather. So we have 88% of this price is now the new value in 2022. So when you use your calculator to divide, and we can actually cut out the zeros. So let's multiply using our calculator. This would give us 2,332,000. Okay. So since we already have million here, so we need to divide 1, 2, 3, 4, 5, 6. So the answer is 2.332 million. All right. The next question. The number of people at a football match is 1,455. This is 6.25% of the total number of people allowed in the stadium. Find the total number of people allowed in the stadium. Now this number that we have here is just 6.25% of the people allowed. So that simply means 6.25% of the people allowed is 1,455. So the people allowed would be 1,455 multiplied by 100 divided by 6.25. So when you use your calculator to solve that, the total people allowed there would be 23,280. 23,280. We'll move to the next question. The average attendance increased exponentially. Take note of that. Increased exponentially by 4% each year for the 3 years from 2016 to 2019. In 2019, the average attendance was 1,631. Find the average attendance for 2016. So for this, we're using the formula of compound interest. That's still the same thing as exponential increase or decrease. So we're using this formula, A equals to P into bracket 1 plus R over 100 raised to power of n. So A is the population after the increase. That should be the population in 2019, and in this case it is 1,631. P is the population or the attendance that we started with in 2016, which is what we are looking for. And then we have 1 plus R is the percentage, the rate, and that's raised to power of n, which is the number of years. So I have 1,631 equals to P into bracket 1.04 raised to power of 3. So we can divide this by 1.04 raised to power of 3. Same thing here, 1.04 raised to power of 3. This will cancel out. So P equals to, when you use your calculator to divide that, you would have 1,449.95, which is approximately 1,450. So that means the average attendance for 2016 was 1,450 approximately. Let's move to the next question. Another club sells season ticket for individuals and for families. In 2018, the number of season tickets sold is in the ratio family to individual equals to 2:7. I. The number of family season tickets sold is X. Write an expression in terms of X for the number of individual season tickets sold. So for this is going to be, let me change the color. Okay. So this is going to be, since the number of family season tickets sold is X, then the number of individual season tickets sold will be 7 over 2x. Now you can wonder how we're able to arrive at this answer. There are actually different ways in which you can go about it. We can actually have this as family over individual equals to 2 over 7. We cross multiply. So we have 2 individual equals to 7 times family. And remember, family is x. So we divide both sides by 2. And then individual gives us 7 over 2x. There's also another way in which we can find out the answer, but that seemed to be the easiest. So let's just take that approach. In 2019, the number of family season tickets sold increases by 12, and the number of individual season tickets sold decreases by 26. Complete the table by writing expressions in terms of X for the number of tickets sold each year. So individual tickets in 2018, remember that's from what we have here. That's 7 over 2x. 7 over 2x. In 2019, we're told that the family season ticket increases by 12. So this is x plus 12. While the individual ticket decreases by 26. 7 over 2x minus 26. We'll move to the next question. In 2019, the number of individual season tickets sold is 3 times the number of family season tickets sold. Write an equation in X and solve it to find the number of family tickets sold in 2018. Now let's be very careful. Let's interpret this question. The number of individual season tickets sold is, so what do we have? Number of individual tickets sold in 2019. That's 7 over 2x minus 26. Is there means equals to, is that's equals to 3 times the number of family tickets sold. 3 times the number of family tickets sold. So we have written the equation and then we can solve. So this is 7 over 2x minus 26 equals to 3x plus 36. We'll collect like terms. 7 over 2x minus 3x equals to 36 plus 26. If we subtract this would give us half x, and this would give us 62. So this can also be written as 0 0.5. So you can divide through by 0.5, or you can multiply through by 2. It depends on what you want to do. You would arrive at the same answer. So I'm going to divide this by 0.5. I'll divide this by 0.5, and x would give me 124. So the answer here is 124. So we move to question 2. All the lengths in this question are measured in centimeters. So we have that shape there. The diagram shows a solid cuboid with a square base. The volume v centimeters cube of the cuboid is v equals to x squared into brackets 9 minus x. The table shows some values of v for 0 less than or equals to x less than or equals to 9. We're asked to complete the table. The first question is complete the table. So when you insert 2 into the expression given to us, or into the equation for the volume, this is the volume. So we'll substitute 2 raised to the power of 2, 9 minus 2, and that would give us 4 times 7, which is 28. So this is 28. On the grid on the opposite page, draw the graph of v equals to x squared into brackets 9 minus x for 0 less than or equals to x less than or equals to 9. So we're going to draw that on the grid. Find the values of x when the volume of the cuboid is 44 centimeters cubed. So we need to draw the graph first. So let's do that. When x is 0, v is 0. So we start, x is 0, v is 0. The next one that we have there, when x is 1, v is 8. 1 and 8, that should be, this is 2, 4, 6, 8. 2 is 28. 20, 28 should be somewhere around there. Let's go. 354, 480. 354, 354, 52, 54, 480. Okay. 500, 108. 500, 500, 108. Okay. 798, 864. 798, 798, 798, 864, and 90. So let's join. Let me use a different color to join. Okay, so let's join. I have this, and from here it's always better to join in twos, except you're going to be using your French curve. then you can join at once. From here, I have my answer to be 2.6. This is 2.6, and the other one is 8.2. There would always be range of answers for questions like this. So feel free to use the mark scheme to get your range of answers. So 2.6 or 8.2. Then we move to the next question. It says, show that the total surface area of the cuboid is 26x minus 2x squared centimeters. So let's see. Now, total surface area simply means the areas of the surfaces. That's the meaning. I don't subscribe to students trying to cram formulas. So you can actually get to understand what you're looking for. So in this case, I'm going to use different colors of ink to show the surfaces. Now I have this one I'm shading here, and the one I'm shading here is the same thing as this top side. So I'm going to find the area of that part that is a square, side xx, so that's x square. Remember there are two, so that is 2x squared. That's for the first two surfaces. Now I'm going to shade another part. Look at this side. That's another pair of surfaces. So I have to find the area of the two sides. In this case, the length is 9 minus the length is 9 minus x, and the breadth is x. So the area of the other surface is x times 9 minus x. And remember, there are two, so you multiply it by 2. Then lastly, we have another pair. We have another pair, which is this inner one and then this outer side, which also has the same measurement as this. So that's x into bracket 9 minus x, and they are also 2. So we have this. So let's go back to our page, then would. Yeah, so we have, first one is 2x squared. The other one is 2x into bracket 9 minus x. And then we also have another 2x into bracket 9 minus x. So let's solve this. This is 2x squared plus 18x minus 2x squared plus 18x minus 2x squared. So this will cancel out. I have 18x plus 18x, that's 36x minus 2x squared. And that is what we were told will be the answer. So yes, that's it. The answer is correct. 36x minus 2x squared centimeter squared. So let's go to the last question under question 2. Find the surface area when the volume of the cuboid is a maximum. Find the surface area when the volume of the cuboid is a maximum. What does it mean for the volume of the cuboid to be a maximum? What does it mean to be a maximum? Remember from our knowledge of differentiation, the um, volume, the volume is v equals to x squared into bracket 9. So the volume v is equals to x squared into bracket 9 minus x. So v is 9x squared minus x cubed. So we need to differentiate. We find the v dx, and this will give us 18x minus 3x squared. Now, for this to be maximum or minimum, we have to equate it to 0. So this is 18x minus 3x squared equals to 0. So we solve. Something is common here. 3x is common. And we are left with minus x equals to 0. So we have 3x equals to 0, and that makes x equals to 0. Or we have 6 minus x equals to 0, and that makes x equals to 6. So All we need to do is to substitute the value of x into our formula, that is 36 into bracket 6 minus 2 into bracket 6 squared, and use your calculator to solve this. This is going to give us 36 multiplied by 6 is 216. 216 minus 6 square is 36, and when you multiply that by 2, it's going to give us 72. So 216 minus 72 would give us 144. So the answer is 144. All right, you can also pick out your maximum value from your graph. You can pick out your maximum value from your graph. This is the maximum value, and that's why we're actually using 6. This is the maximum value. So if I have my maximum value there, this is the maximum point here. So I will pick my x value. If you trace it down here, you see that your x value is 6 at that point. So yes, so that's why we're using 6. All right, we'll move on to question 3. Kai and Anne carry out a survey on the distances traveled in kilometers by 200 cars. Kai completes the frequency table for the data collected. Calculates an estimate of the mean. Okay, so for us to calculate the estimate of the mean, we have x. We also need our f, and then our fx. X is the midpoint, so we have to do 80 plus 100 divided by 2. That will give us the first value for x, and that's 90. Our frequency is 7, so 90 times 7 would give us 630. We'll move to the next one. The midpoint is 100 plus 150 divided by 2, and that will give us 125. The frequency is 33, so when you multiply that, you have 4,125. The next one, midpoint 150 plus 200 divided by 2, and that will give us 175. The frequency is 76, so when you multiply that by 76, it will give us 13,300. Our next point to be 200 plus 300 divided by 2. That is going to give us 250. The frequency is 52. So when you multiply that by 52, we have 13,000. 13,000. Then lastly, we have 300 plus 400 divided by 2, and that will give us 350. The frequency is 32. So when you multiply that, we have 11,200. So remember, our mean is summation fx over summation f. So mean is, we're going to add up all of the numbers we have there. That's 630 plus 4,125 plus 13,300 plus 13,000 plus 11,200, and that would give us 42,255 divided by 200, which is the frequency, and that will give us 211.275. 211.275 kilometers. That's the mean. Okay. And uses this frequency table for the same data. There is a different interval for the final group. So you can see everything seems to be the same thing except the final group, except this group. You can see In this case, the interval used at this side was 300 to 400, while in Ant's case, the interval used was 300 to 360. So, yes, and then the frequency remains the same. Without calculating an estimate of the mean for this data, find the difference between Ant's and Kai's estimates of the mean. You must show all your workings. So all we have to do is, because the frequency remains the same, we only need to deal with this last group. So for the last group, in this case, the midpoint is 350. So I have 350 times 32 minus, in this case, the midpoint is going to be 300 plus 360 divided by 2, and that's 330. 330 times 32. So when you multiply this, I think we have already multiplied this earlier. This is 11,200. 11,200 minus, when we multiply this, it's going to give us 10,560. So we're going to subtract that minus this. That would give us 640. So we have 640 divided by 200. 640 divided by 200, and that's going to give us 3.2. So that will be the difference between the estimates of both means. We'll move to the next question. I. A histogram is drawn showing the information in Kai's frequency table. The height of the block for the interval 200 to 300 is 2.6 centimeters. Calculate the height of the block for each of the following intervals. So we're using this frequency table. Now, since we are having different intervals, we need to find our frequency density. The formula for calculating our frequency density is frequency divided by class width. So let's go. For this one, for this first one, it's going to be 7 divided by 20. 7 divided by 20, and that's 0.35. How did we get 20? That's 100 minus 80. That's the class width. So the next one will be 33 divided by 50. And that's going to give us 0.66. The next one is 76 divided by the next one is 76 divided by 50, and that would give us 1.52. The next is 52 divided by 100, and that will give us 0.52. And lastly, 32 divided by 100. 32 divided by 100 would give us 0.32. Now from the question, this particular one that gave us 0.52 is now 2.6 according to the question. So 0.52 multiplied by something that we don't know is 2.6. So we need to find out what was used to multiply. We need to find the scalar that was used to multiply. So 2.6 divided by 0.52 is 5. So that means the scalar used to multiply is 5. So every other thing, every other frequency density would also be multiplied by 5. So let's go. 80 to 100. 80 to 100 is 0.35. So we're going to multiply that by 5. 0.35 times 5. So this is 1.75. The 150 to 200, 150 to 200 is 1.52. So we have 1.52 times 5, and that will give us 7.6. So this is 7.6. And lastly, 300 to 400 is 0.32. So 0.32 multiplied by 5 would give us 1.6. So this is 1.6. Okay, move on. Question 3b. One car is picked at random. Find the probability that the car has traveled more than 300 kilometers. More than 300 kilometers. Okay, more than 300 kilometers. How many cars have traveled more than 300 kilometers? We have 32. So that's 32 out of 200 cars. 32 out of 200 cars. 32 out of 200 cars. Of course, you can reduce this to the lowest term. This is 4 would go in both numbers. 32 divided by 4 is 8. 200 divided by 4 is 50. You can reduce further. 2 would go in this 4. 2 would go in this 25. So answer is 4 out of 25. You could also leave your answer as 32 over 200. So we go to C. 2 of the 200 cars are picked at random. Find the probability that I both cars have traveled 150 kilometers or less. Okay, so 2 of the 200 cars, that means we are still considering 200 cars as the total. Find the probability that both cars have traveled 150 kilometers or less. So our total is 200 cars. So let's check. Let's go back to the table. How many of these cars have traveled 150 kilometers or less? So 150 kilometers or less, that's 33 plus 7, that's 40. So we have 40 over 200 times 39 over 199. I know you might be saying that, but we're not told there's replacement or without replacement, but you need to know that when you pick a car, definitely the number of cars would reduce. So either you're told that is replacement or not. There are times you need to apply knowledge of what would happen in real life or real life situations. So when you multiply this, our answer would give us 39 over 995. And the next one here says one car has traveled more than 200 kilometers and the other car has traveled 100 kilometers or less. So let's go. What do we have more than 200 kilometers? Now you might be wondering, we're not told which to use. Is it Kai's table or Anne's table? It's actually going to give us the same answer. So more than 200, we have 52 plus 32. 52 plus 32, and that's 84 over 200 multiplied by 100 kilometers or less is 7 multiplied by 7 over 199. Now we're not told that this was picked first and this second. Neither were we told that this will be picked first and this will be picked second. So because of that, we actually have two possibilities to this. We have two possibilities. So we're multiplying it by 2. Multiplying by 2. So you get your calculator, multiply 84 divided by 200 times 7 over 199 times 2. This will give us 147 over 4,975. All right. So we move to question 4. Question 4 says, describe fully the single transformation that maps shape A onto shape B. So let's see. Shape A, this is shape A onto shape B. Now, by observation, you can see that the orientation of the shape is the same thing. The size of the two shapes are also the same thing. That simply means It's translation. Translation does not change the orientation or the size of the shape. So that's translation. Translation. Now for it to be translation, we need to get the vector in which it was moved. So let's see, I'm going to pick corresponding point like I'm doing here. So let me count. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So that means it is 7 minus 8. So that's the vector 7 minus 8. Please, it shouldn't be written as 7 comma minus 8. This is a coordinate, not a vector. Okay, you can as well check so that you'll be sure. Pick another corresponding point. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Shape A onto shape C. Shape A onto shape C. Shape A to shape C. So you can see that shape A onto shape C. So you can see that the orientation has changed. However, the size of the shape did not change. The size did not change, but the orientation has changed, and that should point to what? That should point to what? That should point to rotation. That means the shape has been rotated. Rotation. Now that we know is rotation, so we need to get the center of rotation and also the direction of rotation. Like I do explain, you can use your tracing paper to get the center and even the direction easily. All you need to do is to get a piece of your tracing paper, place it over the object, trace it out, then try different center of rotation and rotate either clockwise or anti-clockwise, and then you see if you will get to your image. So since you're writing a paper test, it's not a CBT test, you can actually get your center of rotation manually by trying different points. So, but because we are not using a tracing paper on the screen, so I'm going to try different points here. I'm going to try this point first because I'm not using a paper. So I'm going to try this point first. So I have this. Now, if I try this point, that means I have to rewrite the coordinate here. So the coordinate here becomes -1. I have to move. This is the center now. -1, -2. So this is -2, comma 0. So I would look for um the position. Remember, I explained this in the last question that we solved, but I'm going to say it again. Now, if you are rotating 90 degrees, if your coordinate is x comma y, it's going to turn to -y comma x. So take note of that. So I'm going to check the coordinates of the corresponding point. Now, if you look at the way this diagram is, look at the way the diagram is, look at where this corresponding point is, you realize that it's actually moving 90 degrees anti-clockwise. Now, with a lot of practice, you'll be able to identify easily. So this is moving 90 degrees anti-clockwise. So we need to get the center. Now this is my new point, -2 comma 0. So that means this point also should actually be 0 comma 2. But let's see, this is the center. This is 1, 2, 3, and this is 3 minus 1. So definitely this is not the center of the rotation. So I'm going to pick another center randomly, remember. So I'm going to pick this. So if I pick this, this becomes my new center. So I'm going to look out for the coordinate of this using my new point. So this is 1, -1, -2, -3, and then -1. So this is -3, -1. If I rotate this 90 degrees, it becomes +1, 3. So let me see. 1, 2, 3. This is 1, 2, 1, 2. So no, it's not this. So I have to change the point again. I'll change the point to this. So I'm going to change the point to this. Let me take the reading from this new point. So if I take the reading from this new point, it becomes 1, 2, 3, 1, 2. That's -3, -2. So let's take the corresponding point. 1, 2. That's 2. 1, 2, 3. So remember, if I rotate this, if this is the center, then it should give me 2, comma, -3. So let's see. 1, 2, 1, 2, 3. So this is 2, comma, -3. And that's it. So that means the center is 0, comma 8. The center is 0, comma 8. So like I said, you can always use your tracing paper to check. You can always use your tracing paper to check. So let's move to the next one. Shape A onto shape D. Shape A onto shape D. From mere observation, you can see that um, the orientation did not change. However, the size changed. So that means this is enlargement. Now, I know some people want to say, why is it not reduction? No, we don't use reduction. Instead, we use enlargement, but with a scale factor that is a fraction. So there's nothing called reduction. We use enlargement. So now that we know that is enlargement, let's see, what do we need for enlargement? We need the scale factor, and then we also need the center of enlargement. For the scale factor, let's observe the scale factor. Let's see, we have 1, 2, and then we have 1. So basically it looks like half of this. So the scale factor is 1/2. And because the orientation is still the same thing, it's not negative. So the scale factor is 1/2. Then the center, find the center. It's quite easy with this. All we have to do is to draw our straight line connecting the corresponding points. You have to be very careful. Draw it. And you actually don't have to join all the points. You can join 3 points, or 2 points is just enough. Get your ruler and join the corresponding points. Now, if you join your points properly, you realize that the points you have joined, or the lines that you have used in joining the points, would all meet at one point. So you take the coordinate of that point, and in this case it is -1, comma -4. So that's the center for enlargement. So the second question says, on the grid, draw the image of shape A after a reflection in the line y equals to x plus 8. Okay, so line y equals to x plus 8. You find when x equals to 0, y is 8, and when y equals to 0, x is -8. So you plot that. X is -8. You can actually erase this. You can erase this. Then y equals to 8. Now let's look at what are we reflecting, shape A. Okay, so let's clean this part to make the work easier for you all to see. So I have y is 8 here. So you join the 2 points that way, you get your ruler and you join the points. So we are reflecting this shape. You can see that the first point is just right there on the line. So we are reflecting into the line. Then the second one is halfway into the line. This is from here, just halfway. So we are going halfway to this point here. This is also half. This place is half. So here. The point here is half. Also going to be half here. So then lastly, we have, I think we have 5 points. So yes, lastly we have this point. This is 1. This is half. This is half. This is 1. So let's join the points. Let's join the points. We have this to this, this to this, this to this, and then this to this. So yes, make sure you use a ruler so you can get a perfect shape.